Okay, Assalamu alaikum, Ashraf. Welcome back to the class, and I wish that everybody had an enjoyable, healthy, safe weekend. Can you all hear me?
Yes.
Yes.
Yes, doctor.
Okay, good. There is some announcement that I need to make, but since some of them are very important for all students to hear, I will probably delay them for later time until everybody is here. Students are still joining in, so we'll make those announcements later. Let's start by quickly reviewing what we have talked about. This is our slides with my marking on it. In this slide, if you recall, what we did was to say if we have an element with multiple stresses acting on the XY, this is a general plane stress problem. General means the maximum load you can put in a plane stress problem. So you will have tau xy, so you have 3 stresses. And we said, some of you even asked, if I remember from your section or the other, said, what happened if we look at the stress at a different angle, which is very important question. And what we argued is that depending on the magnitudes and the direction of these stresses, okay, it is not straightforward answer. You know what happened at any given plane? It's not a straightforward answer. And because stress is a field, as I told you many times, you can actually, ya shabab, have infinite number of planes which you can cut the material with and get a different value for stress. So we have a relation that was already established for us by cutting the element using a plane phi, an arbitrary plane, okay? And then by changing the angle, sigma x, sigma y, tau xy will not change. We're just changing the angle, which means the load is the same, but we are looking at the material at different directions, okay? يعني يا شباب مثال بسيط. If God forbid you got injured, God forbid, يعني you slipped or something, and then you are doubting that you broke your leg or your arm, you're doubting, okay? يعني الآن رجلك انكسرت، انتهى الموضوع. الطبيب لما يجي ويحاول يضغط يقول لك في ألم there it is. We just found it. They put you in the X-ray, try to move يمين يسار تحت فوق until they found the crack, for example, if it is not complete fracture. So it's the same way. The load is the same, everything is, we're just looking at different angles. So by changing those angles, we will obtain different values of sigma and tau, which are the normal and the shear stress. And then we ask the question, where is the maximum and how much is it? It turns out that we can arrive to a closed form solution, which is very much something you know from previous CE 203. This is called the principal stresses. And these are called the maximum shear stresses. There are 2 values of them. We are acting in a plane, right? In a plane. And one of them is larger than the other. And similarly, this is the same with tau. The equation, I think you are familiar with it. And the orientation where sigma 1 and sigma 2 will reach their, corresponding values, and tau 1 and tau 2 will reach their values, are considered to be phi n and phi s. This is S stand for shear and N for norm. Good, ya shabab. Now, it turns out that this whole plane stress, we call it plane stress transformation. Why do we call it plane stress? Because it is 2D and we are assuming that there is nothing in the depth. And it is transformation because you are transforming the angle, the state, you are looking around. It turns out that there is a graphical representation of this transformation, which was done by Mohr. Mohr is an engineer or scientist who established the Mohr circle. It was named after him, okay? So Mohr circles stand into quantities. That's it. The first one is a center. The second one is a radius, which is very basic, right? We know that if you want to draw any circle in life, all what you need to do is to tell me how much is the radius and where exactly do you want me to put the center. That's it. If you have this page, like for example, and I told you I want to draw a circle, you'll tell me where? Here? That's the center. Do you see it? And then I draw the circle. I told you, no, here. And then I draw the circle. And maybe I tell you, yes, it is here, but I want it to be bigger, something like that. So without further delay, because this is something you know, and I'm just trying to refresh your memory. The center of Mohr circle is called the average stress. All what you need to do is to take the average of the normal, which means if you just average you add the two values of the stress, normal stresses, which are sigma 1 plus sigma x plus sigma y. There is no sigma z. And then you divide them by 2. That's it. Now, what you need to be careful about is that this is independent of their values. This equation is just the addition. So one of them could be negative. Both of them could be negative. It doesn't matter. Then we talked about the radius, the second important quantity, which is given by this equation. It's the square root of sigma x minus sigma y over 2 all square plus tau xy squared. Again, this minus sign is coming from the equation. So if y is negative, you will have minus minus. If y is negative and sigma x is negative, you will have minus plus minus. They will be added. But the square will always even them out, will make them even. So you will not get an imaginary solution. Good? The idea is that whether sigma x and sigma y are joining forces to make an effect, or they are, competing. One of them is subtracting from the other. That's a totally different question. Similarly, tau, ya shabab, is squared. So it doesn't matter what you put there. Do you put a minus tau or a plus tau? It's just the same, okay? Now, what should you know is that one of the critical things about Mohr circle is that it has a rotation. You will see later, we'll tell you about it, but that in this, at least within machine design, our course, we consider counterclockwise rotation as positive. So if you have a rotation like this, which is counterclockwise, we consider it positive, and negative is clockwise. Now, why this is important, you will see in a minute, okay? Now, another important aspect, ya shabab, is that a rotation of 2 phi twice as the angle in the circle correspond to 1 phi in the material. يعني على سبيل المثال احنا قلنا في المثال اللي في المحاضرة الماضية انه if I have a specimen and I load it under tension, then the plane at which tau is maximum is 45. And we had a discussion in ductile material, if you pull them under tension, there is a good chance that they will fracture at angle 45. Good, ya shabab?
Yes, good.
Okay. Now, you will notice that the location of tau maximum for tensile loading, if you represent it in a Mohr circle, you will notice that tau maximum is located here. This is funny, right? Because definitely this angle is 90. But if you know that it's 90 and this is 45, it is no longer funny. You just know that what is in the circle should be divided by 2 in real life. So if you have a problem, somebody gave it to you from Aramco and they told you, please tell us where is the plane of maximum shear, because we know that the material will fail at that plane. And in the circle, it came out to be 40 degrees. Then you will tell them, listen, from the horizontal, which is the line perpendicular to the, you have to establish a coordinate. You tell them, okay, what is the horizontal? What is the vertical? Then you tell them from the horizontal, look at 20, 40 over 2. And this is where the crack is supposed to start. That's the start. Yeah, that's the idea. You got my point? Okay. Now, so this is the circle. It looks too much. It has too many. But if you look at it carefully, you will understand it very well. First of all, the circle has a coordinate. The coordinate is going to be normal stress in the y-axis and shear stress in the y-axis. Now, apparently, any coordinate system would have a positive and negative. So we will just pick the right-hand side to be positive normal stress and the left-hand side as negative normal stress. And of course, this is 0. There has to be 0 in the middle. And then to the right is positive, to the left is negative. Okay? Tau, ya shabab, tau is also positive and negative. But what we agreed that counterclockwise is positive, so we'll take it up. And tau clockwise is negative down. Now, the question is, while it is very simple to determine whether a normal stress is positive or negative, this is all positive normal stresses. If I make this one in this direction, it is negative. But how do you determine what is a positive shear stress or not? Let me tell you this once and for all, it will resolve all your issues. If this is an element and you established yourself that this one is the positive x direction and this one is the positive y direction. Now look, I am not going to look in here. I am not going to look in here. I don't want to. Why? These are the negative phases of y and x. I don't want them. I'm just going to erase them. And let me tell you what happened. Now, what happened is this. If you have a shear stress, you present it like this, and then you have to put a counterclockwise, a counter stress to it. Now, we know that this is tau, the face x, the direction y. We agreed on this, صح ولا لا? We agreed on it. Now, الحقيقة إنه هذا stress, let me make this blue. The blue stress act in a rotational fashion, clockwise, and the red one act in a rotational fashion, counter clockwise. صح ولا لا؟ الحين انتم ضعتوا وقلتوا الحين وش السالفه؟ هذا clockwise ولا counter clockwise؟ هو في الحقيقه تاو الرد clockwise and counter clockwise, and at the same time the same value has a counterclockwise rotation. So which one is which one? So basically this is what we do. We go and look at the X face. You will notice, ya shabab, that while we are working on the problem, okay, if for example, let's assume you will see that the circle automatically will be this coordinate will be converted into an X face and Y face. This is what's going to happen. Sometimes the X face is in the left and the Y face is on the right. But if the X face is here and the Y face is here, now look what happened. The X face has a tau, okay, has a tau XY, which is, لاحظ, the positive X face has a tau, okay, which is positive. Why? Because it's counterclockwise. So this red one should go in here, while the blue one will go down. Why? Because it's a clockwise. Now I know انتوا شو اللي قاعدين تفكرون فيه انه how can I know which is the X face, which one is the Y face? So we're going to talk about this in an example in a very simple way. But the idea is this. If you construct the Mohr circle like this is here, the 0, okay? You will see that when you draw the circle, it will intersect the X-axis in 2 points. These 2 points, the maximum one will be sigma 1 and the other maximum is sigma 2. ما عندك other than this. The circle has no values in the middle, no values outside. It is represented by this circumference, only this line. كل شيء يصير في المور circle يا شباب around this line. So بالنسبة للسيجما, وين التقاطع مع الإكس axis, you will give you sigma 1 and sigma 2. How do you know which one is sigma 1, which one is sigma 2? The maximum is always sigma 1. That's it. Now, at the same time, since this is a circle, it will have at the center a point, which is the center of it. And when you draw a vertical line, automatically that vertical line will intersect the circle at 2 points. One of them is going to be tau 1 and the other one is going to be tau 2. Now, these values, ya shabab, are the one which are extreme. They are the maximum. They are the maximum. هذا اللي أنت تبغى تطلعه، هذا اللي أنت ما تعرفه. السؤال, where is the stress state now اللي انت تعرفه، اللي احنا نجي ونعطيك اياها زي كذا، نقول لك 50 سالب 100 ومثلا 40. لما نعطيك state like this, where does this exist in the circle? Well, it's going to be somewhere within the circle, but presumably it is not here or there. Why? Because usually you have the stress state somewhere here, and then what do? Ya shabab, you rotate in order to bring the state here to find the maximum normal stress, which is the principal sigma 1 and sigma 2, and then you rotate to bring the element here in order to find the maximum shear stress, واللي هي tau 1 and tau 2. Okay, so I think I removed from the slide an example. Let me tell you this. We have been asked to draw the Mohr circle, determine sigma 1 and all other values if we have sigma x equal to 6 megapascal, sigma y equals to minus 5 megapascal, and tau xy equals to 8 megapascal. What? Counterclockwise, which means it is positive. Okay, so when we are asked about this, well, the first thing what we are going to do is to find the center of the circle. We will call it C from the center. C equals to sigma x plus sigma y over 2, which is equal to 6 plus minus 5, is that right? Divided by 2. And this is going to give you 0.5. ليه؟ 6 ناقصا 5 1 تقسيم 2 نص. صح؟ Now, we go to the radius r. The radius, as you know, is the square root of sigma x minus sigma y over 2 square plus tau xy square. So this is equal to the square root of, again, 6 minus 5 divided by 2 square plus 8 square. Good? Good, ya shabab. So this is going to give you, of course, طبعا يا شباب للمعلومية المور circle any value فيها هي stress. So this one is 0.5 megapascal and this one is 9.71 megapascal. Good. Now what are we going to do? We are يعني باختصار انتوا الان لا ما رسمتوا السيركل الى الان. لاحظوا يا شباب سيجما 1 في الحقيقة هو the center plus the radius. ليه؟ خلوني أرجع بكم شوية. Look at sigma 1. Sigma 1, this is the radius, the center I mean, which is sigma x plus sigma y over 2. هذا الافرج هذا اللي هو السنتر. وهذا اللي هو الراديوس. So if I add them, I get the bigger value. If I subtract them, I get the negative value. اللي هي مو negative أقصد, the smaller value. So ومو بس كذا, لاحظوا إنه tau 1 and 2 is plus or minus the radius. This is the same, which is the radius. So if I go back to my solution, I would say sigma 2 equals to C minus R. So for this one, I have 0.5 plus 9.71, which is going to give me 10.21 megapascal. And for this, I have 0.5 minus 9.71, which is equal to minus 9.21. Yes? Ali?
Nothing.
Okay, good. Do you see that يا شباب؟ طيب الراديوس عرفناه. الراديوس tau 1 will be equals to R و tau 2 will be equals to minus R. That's it. Now, what are the angles? If you recall, the angles يا شباب are like this. احنا عندنا هنا for the normal plane we have tan 2 phi 2 tau xy divided by sigma x minus sigma y, and the inverse of it, which is minus sigma x minus sigma y divided by 2 tau xy, is the tan 2 phi for shear. So if I go back to the solution, I need more space. So what did we say? We say that tan 2 phi normal is equal to sigma x minus sigma y divided by tau xy, and tan 2 phi s equal to minus 2 tau xy divided by sigma x minus sigma. لاحظوا يا شباب, it's a function of what you apply. So you change what you apply, you change the plane. So what do we have here? We have 2 phi n equals to the tan inverse of sigma x. كم كانت يا شباب? Anybody remember?
10.7.
It was, no, sigma x was 6 megapascal.
Yeah.
And then minus 5 divided by twice is what? 8. Okay? And when I do this, I need to divide by 2. And the result would be phi n equal to how much? It will be 27.75 degrees. And it is what? If it is positive, ايش قلنا احنا يا شباب البوزيتيف؟ معناها counter clockwise. بنعلمكم ايش معنى هذا لما نرسم. طيب, what is phi n? It will be tan inverse over 2, and then 2 multiplied by 8 divided by 6 minus 5. And this is going to give you how much? 17.25 clockwise. ليه؟ طلعت negative. Why? Because, I forget, by the way, to put the negative over here. We have a negative sign, so it is a clockwise. Now, there is another equation يا شباب نقدر نستخدمها, وهي phi s is equal to 45 degrees minus phi what? Normal. And this is going to give you 45 minus how much was the angle? It was 27, okay? 27.75. And the idea here is that you would need to know what is the direction of that. So let me show you how we are going to get the direction, okay? Let me show you how are we going to get the direction. Now, if you plot the coordinate like this, such that this is sigma, this is tau counterclockwise. لاحظوا يا أخوان, إحنا في المور سيركل شو نسوي؟ نجي نقول علمني where is the center في البداية. أنا أقول لك السنتر هنا. السنتر كان قليل مرة 0.5 كان 0.5 ميجا باسكال. السنتر موجود على الإكس أكسس. طيب إيش باقي؟ باقي الراديوس. الراديوس the center was 0.5 والراديوس كان كم؟ 5
9 دكتور 9.71.
Oh صح, radius كان 9.71. Yeah, it's correct. No. 9.71. Now المهم في الراديوس شنو؟ انك انت مفروض تحسبه من وين؟ من السنتر, صح ولا لا؟ فاذا كنت انت عند نقطة نص هنا لازم الى اليمين تمشي 9.71. So if you go from here to here 9.71, how much is the distance from here to there? بيصير 9.71 plus 0.5 اللي هو سيجما سيجما 1 بالضبط. So this one is indeed sigma 1, which is equal to how much? 10.21. Now لاحظوا, عشان أنا أطلع الراديوس أو البوينت على الأذر سايد أبدأ من 0.5 و I need to add how much? 9.75, but in the opposite direction. And this is what is going to give me minus 9.21, which is sigma 2. فاهمين؟ الآن أنت لو عندك كامباس اللي هو فرجار, you will be able to draw the circle. انتهينا يعني, صح? You don't need to struggle. But if you think about it, going from this point all the way up where the circle is going to intersect a point, this point will be how much? Is the radius. صح ولا لا؟ الدائرة إذا جيت أنا من السنتر ومشيت هنا هذا راديوس، مشيت هنا هذا راديوس، هذا راديوس، صح ولا لا؟ So هذا الديستنس هو الراديوس. تذكرون الراديوس كم؟ هو 9.71. So this value over here is 9.71, which is tau counterclockwise. في الأسفل راح يكون عندنا هنا أعلى نقطة minus 9.71 or 9.71 clockwise. Now, until now, يا شباب, I don't think you know why clockwise, why counterclockwise. لكن بس أرسم الإليمنت صدقوني حتعرفون كل حاجة, حتعرفون الستوري كلها. طيب, الآن أنا أبي أعرف البروبلم شو تقول؟ تقول إنه سيجما إكس equal to 6 ميجا باسكال, وتقول إنه سيجما واي equals to minus 5 ميجا باسكال, وتقول بأنه تاو إكس واي equals to 8 ميجا باسكال وشو counter clockwise. الآن أنا أبغى أجي وأرسم هذا في السيركل. كيف؟ well, أنا أجي حق السيركل يا شباب وأحسب من السنتر وشو؟ أحسب كم يا شباب؟ Anybody would expect?
6 to the x and minus 5 to the y.
شوفوا يا شباب, خلينا نبدأ بطريقة, خلينا أعلمكم أنا. This is the element, شايفين؟ سيجما x 6, سيجما y سالب 5, وتاو اكس واي, التاو اكس واي راح تكون بوزيتيف كاونتر كلوك وايز. نجي على البوزيتيف اكس اكسس ونكتب 8 كاونتر كلوك وايز. good good يا شباب.
Good.
okay, now there is only one thing I think I need to comment on. معليش يا شباب, أنا I need to go back here and explain one thing. إيش اللي صاير? Probably في civil engineering you put counterclockwise on the top, clockwise on the bottom.
دكتور,
In machine design, yes.
قبل شوي قطع.
Okay, can you hear me right now?
Yes.
Okay, good. Everybody, are you okay?
Yes.
Yes, doctor.
Okay. Okay. Now, I forgot something, that in this course, we are going to put clockwise on the top and counterclockwise on the bottom. It doesn't make any difference. It's the same. لكنه أنا بدال ما أحط اللي في راسي, خلونا نتبع الكتاب, لأنه in the end of the day you will read a problem from the textbook and I don't want you to get confused. So what are we gonna do? زي ما أنتم شايفين هنا, اللي فوق هو clockwise واللي تحت هو counterclockwise. Do you understand that? Anybody has a problem with this? ما يفرق, صح? Tau clockwise up, tau counterclockwise down. Are we okay?
Yes, doctor.
Okay, let's hope so. So if this is the case, I need to make few corrections here. I will make this one 9.7 clockwise وهذا 9.71 counter clockwise. بس هذا أهم شيء. طيب الآن وش اللي راح نسويه؟ راح نجي ونحلل الاليمنت زي ما أنتم شايفينها يا أخوان. البوزيتيف اكس اكسس عليه 8 counter clockwise وفي نفس الوقت عليه سيجما equals to 6. الآن أنا بسألكم هذه النقطة هي نقطة الزيرو. على اليمين عندنا بوزيتيف وعلى اليسار عندنا نيجاتيف. في نفس الوقت أنا أتكلم عن النورمال. أنا عندي الإكس أكسس بوزيتيف عليه بوزيتيف ستريس والواي أكسس is نيجاتيف ستريس. شو إيش صار؟ صار يا شباب لا إرادياً أنا مضطر إني أختار هذا الجهة هذه تكون إيش؟ الإكس فيس والجهة الأخرى تكون الواي فيس. ليه؟ خلوني أشرح لكم كيف. لو لاحظتوا إنه أنا لو جيت بقيت أحدد الإكس فيس، الإكس فيس لازم يكون عليه سيجما بوزيتيف 6 وتاو كاونتر كلوك وايز 8. لو أنا هنا 0.5 إذا 6 is somewhere here. صح؟ خلاص بعد ما عندي حل، هي مو على اليسار على اليمين. طيب where is 8 counter clockwise؟ 8 counter clockwise تحت هنا. شو اللي راح تلاحظوه؟ اللي راح تلاحظوه بأنه I need to erase this just to make it right. I'm sorry, I'm trying to make it colorful, but I am paying the cost right now. So إيش اللي صار؟ اللي صار إنكم راح تلاحظوا if you draw a perfect circle, you will realize that the intersection of the 6 megapascal with 8 counterclockwise will be along the circle down. هذا نقطة الانترسكشن. لازم تكون على السيركل. احنا ايش قلنا؟ قلنا الفضاء اللي داخل السيركل has no meaning. Outside the circle has no meaning. So this point now, what does it represent? It represents sigma x equal to 6 megapascal, and it represents also tau, which is 8 counterclockwise. لو مثلا يا شباب بغينا نحل السؤال واحنا حاطين counterclockwise up، النقطة هذه بتصعد هنا، يعني بيصير لها بس reflection. فاهمين؟ We will keep it down. الآن يا شباب خلاص انتهى الموضوع. أنت تبقى تعرف إذا حلك صحيح، اعمل التالي. تعال وجيب الخط، شايف السنتر حق السيركل؟ Draw a line between the point and the center. Precisely, automatically, that line اللي هو يعتبر كأنه the center line of the circle, it will intersect the circle on the other side. وراح يكون يا شباب مقدار الاكس السيجما هنا -5 ومقدار التاو هو كم؟ 8 clockwise اللي هو هذا. ليه؟ لأنه إذا هذا طلع up counter clockwise هذا راح يجي بالعكس، المقدار نفسه 8 لكنه حيكون clockwise. باختصار لو بقيت أنا أرسمها من جديد يا شباب عشان أتأكد إنكم فاهمينها، the center of the circle is located here. The circle will intersect point here, and point here, and point there. These are the values of maximum. And it will make a circle like this, okay? Now, what happened is that when we determine the point which has a value of 6 megapascal, 6 ميجا يا شباب تنحسب من هنا، والتاو اللي هي 8 counter clockwise تنحسب من هنا. This is 8 counter clockwise, and this is 6 megapascal. The intersection here. Now, all what I need to do is to draw a line between this point and the center of the circle. Automatically, the other point will have -5 megapascal as normal stress, هذا -5, and it will automatically have a value here which is 8 clockwise. Do you see that? Now, if you look at the element, الفيس اللي عليه 6 megapascal هو الX, and this one 8 counterclockwise, while Y will have 8 clockwise and -5 megapascal. So automatically يا شباب, we ended up having this part representing the X face and this part representing the Y face. خلصنا? Now, let me, yes يا وليد.
دكتور 6 ميجا باسكال نحسبها من الاوريجين حق الدائره ولا حق الاكسس؟
من الاوريجين.
تمام.
اوكي.
طيب يا دكتور.
يس.
السنتر 0.5. لكن ما في دلاله على الاكس ولا على الواي ولا. السنتر يا فارس, السنتر السيجما is a normal stress which is sigma x plus sigma y over 2. It must be على الاكس axis. It must be. Always دكتور السنتر على الاكس axis.
Yes.
Thank you.
Okay, welcome. Okay, now the last point is this. احنا شو نسوي الان؟ لاحظوا يا شباب وش نسوي؟ نجي نقول okay, I'm gonna plot the element like this. هذا x وهذا y. Okay. Now إذا تذكرون الفي n كانت 27.75 counter clockwise. ايش معنى الكلام هذا؟ معنى الكلام انه الاليمنت اللي محطوطه الان هذه الاليمنت is here. صح؟ And in order to go to the principal value, I need to take this element and rotate it and bring it here. يعني الاليمنت هذه معذرة الاليمنت هذه I need to bring it right here. In order to bring it right here, I need to rotate counterclockwise 27.75. هذه 27.75 هي ايش؟ هي في الحقيقة في الرياليتي في السيركل it is 2 phi n. So في السيركل you need to have twice this value. Now in reality, what does this mean? It means that if I rotate the element from the horizontal, أنا assuming إن الآن قاعد أطالع الماتيريال والhorizontal هو الx axis. If I rotate it by 27.75, I will get an element right here. And this element will have, لاحظوا يا أخوان, look at this is very important. الاليمنت هذه بتكون هنا وبيصير عليها في الاكس اكسس وشو؟ هذا الاكس فيس الاكس فيس راح يكون موجود هنا والواي فيس راح يكون موجود في الاذر سايد. So the x face will be coincident with sigma 1. عشان كذا الاكس فيس راح يكون عليه 10.21 والواي فيس راح يكون عليه وات؟ سيجما 2 اللي هو ماينس 9.21. او انا اذا حطيتها نيجاتيف ما يحتاج احط نيجاتيف ماينس ساين. I will erase it. Do you see that? طبعا this is going to be like this and this one is going to be like that. Now if I rotate the element, this is x and this is y, this is the original element. If I go back, what you will see? You will see ان element اللي موجودة هنا لو اعكس الروتيشن واجيبها clockwise واحط element هنا، element بتكون على اللوكيشن where you have tau maximum on the bottom and tau maximum on the top. الفرق فقط انه هذا clockwise وهذا counter clockwise. So what will happen يا شباب? We will have this element rotated clockwise down. كم المقدار؟ 17.25. Now لاحظوا يا شباب، لما الاليمنت تجي عند النقطة هذه يكون شوية تريك الموضوع فيها. هذه لأن هي جات هنا الفاليوز على اللاين هذا ما فيها إلا normal stress. There is no shear. So you will only have sigma. However, if you go down, down here, what do you have? You have average stress, which is 0.5. At the same time, you have tau, which is maximum. So, how are we going to represent the element? راح نجي ونقول كم الماكسيموم شير؟ الإكس فيس راح يكون عليه الماكسيموم شير which is counterclockwise 9.71 والواي راح يكون عليه clockwise 9.71 and we will have on top of it what? 0.5 everywhere. ليه 0.5 everywhere يا شباب؟ and ليه why it is stress tension not compression؟ لأنه يا أخوان سواء كنت هنا أو كنت هنا الفاليو هذه هي سيجما افريج والسيجما افريج طلع معانا plus half. So all faces will be subjected to a normal stress which is plus half. However, the y face الx face حينزل هنا والواي فيس حيصعد هنا. فش اللي راح يصير؟ راح يصير الواي فيس عليه clockwise والاكس فيس عليه counter clockwise. I assume you are a little bit confused, but when you go and try it yourself, you will be better. Now let me, شباب, I need to take the attendance. It's already too late. I would like to tell you that I am gonna postpone the quiz يا شباب. ليه؟ For one single reason. كان عندي توقع اليوم إنه أنا أقدر أخلص المور سيركل وأنتقل للبريشر فيسل. The pressure vessel is assigned in your homework. أنا طلبت من الكوردينيتور يأجل الهومورك إلى بعد الناشونال داي بريك وافقوا كل الدكاترة. صعب إني أطلب منهم يأجلوه زيادة. فإذا أخذنا المحاضرة القادمة كويز ما راح يبقى عندنا وقت حق البريشر فيسل. So I would rather delay the quiz than delay the homework. So I'm gonna post this in the blackboard إن شاء الله يا شباب. I think it is too late now. I don't need to take the attendance for this class. Okay يا شباب. Thank you so much. The quiz will be delayed يا أخوان.
Thank you.
دكتور
يعطيك العافية.
when will be the quiz?
Most likely أنا ما أحب إني أخلي الكويز مباشرة بعد البريك.
ايوه بالضبط دكتور.
So I would either put it Tuesday after the break or Thursday after the break. We'll decide inshallah on Sunday. But be ready, huh? We'll decide this next class. Yes.
دكتور الملف اللي بالاكسل لازم نحدد اسم المجموعة ولا نخليه زي ما هو؟
يا نسيت أنا حد أقول لكم يا شباب. أنا I shared the Excel sheet for you to go and write either a distinct code or number so the group I can identify. Each group مثلا 3 طلاب يجوا يختاروا اسم معين للجروب ويحطوا نفسه كابي بيست بحيث إني أتعرف عليه لأنه بدأوا الإيميلات and start to become very confusing. The sheet is already posted on the Blackboard. You can go there, find your team member and put for them a group name, distinct group name. ها لازم يكون مميز عشان ما تتلخبط الأمور.
دكتور
Yes.
طيب هل ماكسيموم 3 ولا اقدر احط 4 في الجروب؟
No, maximum 3.